Okay, Torres, this is John. I'm about to do my video, so here goes. Okay, so this is number one. The original is on top. That was what's on the test. This is the first one I missed. And I'm changing the numbers to 3 over n times the bracket 4 minus the frequency of 1 plus 3i over n quantity squared and close bracket. So first I have to find delta x, and that would be b minus a over n, but we're solving for b minus a, and we know that the answer is 3 over n. So we don't know b or a yet. And then our xi is this, so 1 plus 3i over n. And this gives us a. This is how we know a. So therefore, a equals 1. Now, that means that our f of x is the 4 minus and x squared. This is x. All of that is x. So now, b minus a over n equals somehow 3 over n. And now we know a is 1. So b minus 1 over n equals 3 over n. Therefore, b equals 4. So then what that means is that 4 is on top because it's b, and then a is 1, and then f of x is 4 minus x squared dx, and that's the answer. Okay, so this is number 3. That's the original question, and what I'm changing is the ladder size to 14, and then the feet from the building is now going to be 5, and then I'm going to change the rate to 1/3 feet per second. Okay, so here's my triangle right there, and so the ladder is right here. This is how far away it is from the building, which is y. And so using x squared plus y squared equals z squared, 5 squared plus y squared equals 13 squared, y squared plus 25 would equal 169, so y squared would equal 144, therefore y will equal 12. So we know that y now equals 12, and now I know I need to use a squared plus b squared plus c squared eventually, but we're looking for a rate. So what I have to do is take, hold on, this is not right. A squared plus b squared equals c squared. But since we have to find a rate, I now have to take the derivative. So this is 2a dA over dt plus 2b dB over dt equals 2c dc over dt. Now over here, I'm going to change this to an a equals 5, b equals 12, and a c equals 13. dB we don't know, and that's dB over dt. And then dA over dt we know is the 1/3. And then the dz over dt is 0 because the ladder does not change size. So now we can plug all that in that we know. So A is a 5, dA dt is a 1/3, plus 2 times b, which would be 12. dB dt we don't know, so we're just going to leave that. And it would equal 2 times c, which is 13, but times 0, so that eventually will become 0. So what we're left is 10/3 plus 24 dB dt, and it equals 0. So now we have to solve for dv dt. So what we do is we subtract this over, so a negative 10/3, and then that would be, there's a 24 still, so we divide by 24, which means the 24 is going on the bottom. So I did not plan for these numbers to be this big, but it'd be a negative 10 over 72, which can reduce to 536, negative 536. And that would be our answer in feet per second. Okay, so this is number 4. The original's on top. So what I did is I just changed the x squared on top to an x cubed. And so when you take the derivative, you have this, which essentially just means you can just plug in the values in for t on the top and the bottom. So we plug in x cubed for t, which would be squared, but then you have to multiply it times the derivative, which would be 3x squared. And then we would plug in 0, but the sign of 0 is always 0, so we can kind of just leave that out. And so our answer would just be 3x squared times sine x cubed squared, which, hold on one sec. Oh, this was squared, so that should be distributed in, which would be 3x squared sine x to the 6th. Sorry. Okay, so this is number 5. That's the original equation with a 3 and a 1 on top. I'm changing that to a 2 and a 0 and leaving n the same. But then I also have to find the error in approximation, which I don't think I even did on the test. So the well, one thing I have to know is delta x for the formula. So delta x would just be 2 minus 0 over n, which is 4, so 1/2. And I'm going to need that for my formula. And so AT would be 1/2 times the function, and you plug in, since I need 4 values, I'm going to have to go in between those two numbers, but I start with 0, f of 0 plus, and then everything in the middle is multiplied by 2, so then f of 1/2, I would go 0, 1/2, 1, 3/2, and then 2. So there'd be 4 subintervals. Now, plus 1/2, 2 times f of 1/2, and then plus 2 times f of 1, plus 2 times f of a 3/2, not a 2. And then to end it all off, just a regular f of 2 bracket, and then multiplied times delta x, which is another half. Okay, so I have all that. Now I'm going to bring this up here, so a of t would equal 1/4, and you multiply that delta x again. Plugging in 0 into f of x would simply get us a 4, and then plus, I'm going to leave the 2, and then plugging in a 1/2 would be a 4 minus a 1/4. So 4 minus a 1/4, and this is 16/4 minus a 1/4. Should be a 15/4. Gotta show all my work, you know. Then plug in a 1, and it'd be 4 minus 1 times 3, plus 2 times, now 3/2 squared would be 4, let's get this over, 4 minus 3/2 squared is a 9/4, so 16/4 minus 9/4 is a 7/4, so we'll put a 7/4 there, plus, and then plugging in a 2 would just get us a 0. So now I have to add all that up, multiply it times a 4, so a of t will equal 1/4 times these will cancel to get a 2 on the bottom. Same with these. So I'll have 4 plus 15 halves plus 6 plus 7 halves, and then the 0 is gone. So then that would be 1/4. 8 equals 1/4 times 10 plus, if you add these together, that would be a 22/2, which is 11, which equals 1/4 times 21, which equals 21/4. And that would be the answer for the first part of the question. Then finding the error, there's another equation, and so that is b minus a cubed over 12n squared times max f double prime, the absolute value of f double prime of x. So did we get all that? Just in case that was not seen, there it is. Now f of x is simply 4 minus x squared. F prime of x would be negative 2x. F double prime of x would equal negative 2. I'm going to need that down here. So first we have a b minus a, which is 2 minus 0, so that equals 2. So that cubed, according to the equations, equals 8. So 8's on the numerator. Now 12 times n squared, n is 4, so 12 times 16 squared, or 16 because 4 was squared, multiplied times the absolute value of the f double prime, which would just be 2. And so you multiply 8 times 2 to get 16, and that would cancel on the bottom, and so we're left with 1/12. And that's all of number